Okay, welcome to my class of science this evening. With me here, your teacher, Mr. A+. I've come with this question. Quickly, let us go through and see how best we can handle it. An 8 kg brick fell from a building under construction. The brick fell from a height of 8 meters. Okay. Then take G as 10 newtons per kg. A, calculate the potential energy. 1, just before it started falling. 2, after falling halfway down. Okay. Then B, calculate the kinetic energy of the brick after falling for 3 seconds. So remember, the first thing is you have to understand the question. Then second, this is physics, full of formulas. So you need to master the formulas. Okay. So let's start with the first one. They are saying just before it started falling. So the first thing that you are supposed to do is to introduce the formula for potential energy. Potential energy. So solution, potential energy is written in abbreviation like this. You say PE is equals to mass times gravitational force times height. That is the formula for potential energy. Then from there, you get back to the information that you are given. Do you have mass in the statement? Yes, mass is there, kgs. That is 8. Gravitational force, which is G. Yes, it's there. 10. What about height? Do you have height? Yes, it's there. So the question says, just before it started falling, meaning it was still there. Okay, so we are going to use the same height, which is 80. So yours here now is just to substitute. Mass is what? 8. Okay, times gravitational force 10. Then times height 80. Okay, then from there you multiply. 8 times 10, 80. 8 times 80, 6,400. So 6,400. Now, let's now consider the SI unit for potential energy, for energy. Remember in physics, if you just read the question like this, you are going to lose a lot of marks. Okay, so units matters most in physics. So the SI unit for potential energy is joules. Okay. So now you have completed your answer. That is the way you are supposed to answer it. Quickly, let's go to the second one after falling halfway down. So now this object started now falling. Now it has fallen halfway down. So we want to find the potential energy of that same brick. So the potential energy will still maintain the same formula because that is the formula for potential energy. When we are dealing with the falling of objects. So gravitational force there is involved. That's why we are using that formula. Okay. So now from there we can substitute as usual. Mass, we are going to use the same one, which is 8 times gravitational force 10. What about height? Because the object started falling down. You see? So according to the statement, they are saying halfway down, meaning half of that distance which we have. So half of 80, because this is 8. So now halfway. So half of 8 is what? 40. So here, the height, you are going to substitute what? 40. Okay. So now 8 times 40, 8 times 10 is 8. 8 times 40, that is now 3,200 joules. Because that is the formula for what? For energy. Others, they call it joules or joules. It depends on where you come from. What is important is the formula, the spelling. But in this case, you don't need to write everything. Just write J there. Okay. Then from there, quickly we can go to other question. Calculate the kinetic energy of the brick after falling for 3 seconds. So the brick now has fallen for 3 seconds. Now let's calculate the kinetic energy. So now the formula for kinetic energy again. Remember, physics is about formulas, as I said. So you say now kinetic energy is equals to half times mass times what? Velocity, then squared. That is the formula for kinetic energy. Then let's now collect data and see what we have and what we don't have. So in this case, do we have mass? Mass is there, 8 kg. What about velocity? In this case, we are not given any velocity. So we have to calculate velocity on our own for us to proceed with the finding the kinetic energy. So how do we find velocity? So velocity, when we are dealing with the free-falling object where gravitational force is involved, the formula for velocity, we just say velocity is equals to gravitational force times time. Okay, gravitational force times time, that is velocity. So here now we can go on. We are saying gravitational force in this case, do we have it? Yes, it's there, 10. Then time, they have mentioned time, 3 seconds. Okay, so from there now you say 10 times 3, that is 30. So velocity was the 30 meters per second. That was the velocity. Okay, so now that you have found velocity, we can proceed with our kinetic energy. So kinetic energy is equals to half, then times mass is 8. You write 8, then times velocity we have found is what? 30. So 30 squared. There is a square on the formula part. So you put 30 squared. So 1 over 2, then times 8 times 30 squared, that is 900. Okay. Half times. So 8 times 900, it's 7,200. Okay. So from there now we can divide by. How many times does 2 go into? Okay. In short here, you can complete it properly. So 1 times 7,200 is 7,200. Then 2 times 1, it's 2. So let's divide by there now. 2 into 72, how many times does 2 go into 72? You are going to find that 2 goes there 36 times. Then 2 into 0, 0, 0. Then this is kinetic energy again. As long as you are you are finding energy, whether kinetic potential, the units will still remain the same. So this is how we handle these simple calculations in a physics exam. Thank you so very much for understanding.